Okay, so what we want to remember to do is, as we know, perimeter is equal to twice the length plus twice the width. If I'm solving for L, that means my L has to be isolated. So we're going to follow like we would normally, trying to solve for a variable. What are we going to move first? There's my L, right? Move the 2W. How do you move the 2W? So that means P minus 2W is equal to 2L. How do I solve for L? Divide by 2. Right. So P minus 2W over 2 equals L. Okay. All right. Does my 2 in my denominator go into my 2 next to the W? Remember, if I'm going to divide what's in the denominator, I have to be able to divide it into every term that occurs in the numerator. So I don't have a 2 in front of the P, correct? So I can't take this 2 into both of these terms, so I'm not going to reduce it. I'm going to leave it like that. All right, so this is A. This is solving for L. B says find L when W is 7 inches and P is 30. Well, we know that L is going to be our P, which is 30, minus twice our W, which is 7, divided by 2. So 30 minus 14 over 2 is 8. 16 over 2, so 8 inches. So please make sure when you're doing this homework that you're not just jumping to this last step and giving me a numerical answer, but that you're manipulating your formula first, solving for whatever it is that they're looking for, and then using that answer to come up with the answer in B. Does that make sense? Okay. All right. A equals 1/2 base times height. That's the area of a triangle. Solve for H. So what am I going to move first? What do you think, Madeline? Okay, so let's move them in bits and pieces. We don't have to do both the half and the B. We can just move the half. So how would you move the half? Why would you say subtract? Because if I want to subtract, I have to see adding on that side, right? Do I see any adding? No. What kind of an operation is going on between the half, the B, and the H? So, by 1/2 or multiply by the reciprocal of 2, right? If I have a fraction, I don't really want to divide by a fraction, do I? So multiplying by the reciprocal is a lot easier. Would you agree? All right, so that means if I'm going to move this 2, which is in the denominator, I'm going to multiply by the reciprocal, which is 2 over 1. So now what I have is twice the area is equal to the B times the H. I need to still solve for H, so how do I move my B? What do you think, Emily? Yeah, always ask yourself what operation is going on and do the opposite of that, or the inverse of that. So we know that H is equal to twice the area divided by the base. So there's my formula solved for H. And then the second part is just always going to be a plug and chug. It's a substitution problem. Okay? My base is 6 inches. My area is 12 square inches. And so I'm going to say 2 times 12 divided by 6 is 24 divided by 6, which is 4 inches. Well, up on top I have 2 times 12. I'm just plugging it into twice the area. So my area is 12. So twice 12 is 24. And my B, which is the denominator, is 6. So I put that down here. And so 24 over 6 is 4. Okay? Okay, so now let's try and do this just with variables. This is the same thing that we do when we solve equations. We're doing the same process. Okay? Here, 9x minus 4y equals 7. So if I want to solve for y, I have to move the 9x to the other side. And how do I move the 9x? Okay? And so what I have is negative 4y equals negative 9x plus 7. And to solve for y, now what do? Divide by negative 4, right? I'm going to divide everything by negative 4. Do I like a negative sign in the denominator? No. So how do I get rid of that negative sign in the denominator? What would I need to do? Elaine. Right. You're going to change every single sign, right? It's like dividing through by negative 1. Okay, I can't just change the sign of these two, right? I got to change the sign of every single term. If I'm going to change my denominator, which is one term, I got to change the signs of all of these. Or pull a negative sign through. Or multiply the top and the bottom by negative 1. All of those are saying the same thing. Okay? So that means this is going to give me 9x minus 7 over positive 4. Does that make sense? Uh-huh. Fine. I can split it. Sure. Yeah, you can say 9 over 4x minus 7 over 4. Sure. Yeah, that's fine. Yeah.
But if you do that, because didn't you say on the other one, like you couldn't do,
I can't cancel in just one term without canceling in both terms.
So if that was like 6 over 2, you couldn't make it, or if like 9, it was 9 over 4x minus 6 over,
4?
4.
Then I could change, then definitely I could simplify that fraction, right? Because I've split it now. It's not one fraction, it's two separate.
So you would have split the other one,
I could have, sure, I could have. Come up, where is it?
right there.
I could have said P over 2 minus 2W over 2, right? Which would be P over 2 minus W. And that would be fine too. Okay. Okay. All right, I think is there one more? Okay. All right, solve for x. That means x has to be isolated, correct? How many times does x appear in this problem? I can't solve if it appears twice. So somehow I have to rewrite this equation so that it appears only once. So think. All right, Madeline? But are they like terms? It's but see, this is 2xy. That's all together, so we can't separate it, right? Danielle? So you're going to say negative 2xy plus 3 is equal to x? Is that what you're saying? Yes. And then you're telling me to do what? I don't know. If I divide by 2x, that would give me 3 over 2x is equal to y minus x over 2x, right? So then I get 3 halves x equals y minus 1 over 2. Oh, that's a little bit more doable, right? Would you agree? But I don't like that way either, really. That's a mess. Isolate it. It's got to appear once. If I asked you to simplify and I told you to factor, what would you do? How would I factor that problem? Wouldn't I? Wouldn't I? Common term? Apply that principle. Apply this principle of factoring and pulling out. Ani?
So 3 equals x, parentheses, 2y minus 1.
Perfect. If I'm pulling out an x from every single term, I've eliminated it from every term, right? Distribute it back. I got to get what I started with. I'm going to get 2xy minus x. If I still had an x here, I'd get x squared when I distributed it. Okay? All right, now what would I do? Remember, the whole idea is to solve for x. And it has to be isolated, which in this case it's isolated, isn't it? I mean, it's by itself. It doesn't appear twice in the problem. So how do I finish isolating it or solving for it? In other words, how do I finish so that I have x by itself and I've moved everything else to the other side? What do you think, Elaine? Yes, I would. So these are factors, and we can divide by factors, right? We're saying x times the factor of 2y minus 1. And so since I'm multiplying by that factor, I can divide by that factor. And so that means 3 over 2y minus 1 is equal to x. Have I solved for x? Yes, I have. You're going to have a problem like this on your homework. Go back and look at this problem, okay? So now, solve for y. We're going to do this again. We're going to apply that same principle that we just learned. Look at the y's. They're on the same side, aren't they? So, but they appear twice, correct? So what are we going to do? Pull out the y, and what am I left with? Equals 28. Y'all with me? Divided by 4 minus x, which is our factor. And that leaves me with y equals 28 over 4 minus x. Now let's finish the problem. If x equals negative 2. So that means I have 28 over, careful, 4 minus negative 2. This is why using parentheses is really important when you're substituting so you don't lose that extra negative sign. Okay? So yes, that is 28 over 4 plus 2. 28 over 6. 14 thirds, which is 4 and...
Please take cover in your neutral location. Please go to your safety location